In our last examples, we can see that the difference now is we have x minus y instead of x plus y inside the parentheses. And so perhaps the better way to think of this is that it's x plus negative y to the sixth power, which then means that in the first position in each term is going to be the x raised to the sixth power, then down to the fifth, then down to the fourth, and then the second position isn't going to be y to the 0th, first, second, third, but it's going to be negative y. The end result is that whenever it is a subtraction question, we just end up with alternating positives and negatives on all of our terms, with the beginning term always being positive. That's probably the easiest way to approach this. So that's what I'm going to do here, is instead of raising negative y to this 0, to the first, to the second, I'm just going to remember to include alternating positive and negative signs on each term. So we can get started with this expansion. So we start off with, again, a blank, and then x to the sixth, and the y is missing. So the next term is going to be minus, and then I'm going to leave a blank for the coefficient. It's going to be x to the fifth, y to the first. Then it's going to be plus, again, alternating positive and negative signs. So I'm going to leave a blank for the coefficient, x to the fourth, y squared. Now we're back to minus, x to the third, y to the third, plus, leave a blank for the coefficient, x squared, y's up to the fourth now, plus, oh, sorry, this one's minus, we're alternating. So we're minus x to the first, y to the fifth, with the space there for the coefficient, and then lastly, we're back to plus, the x is missing, the coefficient space is left blank, y to the sixth. And so if we go to our row 6 on our Pascal's triangle here, 1, 6, 15, 20, 15, 6, 1 is our pattern. So we've got it. 1, 6, 15, 20, 15, 6, and 1 is our numerical pattern on the coefficients. And because it's all variables here, we're finished. So if we want to clean it up a little bit, we've got x to the sixth minus 6x to the fifth y plus 15x to the fourth y squared minus 20x cubed y cubed plus 15x squared y to the fourth minus 6xy to the fifth, and then plus y to the sixth. And so for our last one, we're back to having a number inside the parentheses instead of a variable, and we also have it as subtraction, so we're going to have those alternating positive and negative signs in all of our terms. So we can get going here. Coefficient left empty, a to the fourth. Then it's going to be minus coefficient a to the third times 2 to the first. Back to plus. Leave the coefficient space, a squared times 2 squared. Back to minus, coefficient, a to the first times 2 to the third. And then lastly, we finish with plus, coefficient, the a is missing, and now it's times 2 to the fourth. So we do have some simplifying that we have to do here after we fill in our coefficients. So if we go back to our Pascal's triangle, we can see we're in row 4 here, 1, 4, 6, 4, 1. So I'll fill those in, 1, 4, 6, 4, 1. And so now I just need to simplify each of these terms by multiplying out the numbers. So the first term, 1 times a to the fourth, is just a to the fourth. For the next, it's going to be minus, and then I've got 4 times 2 to the first, or 4 times 2, which gives me 8, and then a to the third. And then the next term here, I've got 6 times a squared times 2 squared, so 2 squared is 4, so 6 times 4, I get 24, and then a squared. Moving on to the second to last term, I'm going to be minus, then I've got 4 times a to the first times 2 to the third, So a reminder, 2 to the third is 8. So I've got 4 times 8 is 32, and then just a to the first, or just a. And then for the last term here, we're back to plus. 1 times 2 to the fourth, 2 to the fourth, 2 times 2 times 2 times 2 is 16. And so we have our result. So a reminder, with the negative instead of a positive inside the parentheses, if we have a minus instead of a plus, a difference instead of a sum, then it just means that we're going to have alternating positives and negatives all the way throughout our expansion, always starting with a positive first term.